Okay, next topic is Wheatstone bridge. What is Wheatstone bridge? It is an arrangement of four resistance, that is P, Q, R and X. So arrangement of these four resistance used to determine an unknown resistance. Here X is unknown resistance. Unknown resistance. So we have to determine unknown resistance X using this Wheatstone bridge. So when the bridge is balanced, we get this equation: P by Q equal to R by X. So here this P and Q are known resistance. Okay, that means we know the value of P and Q, and R is also known resistance. The difference is we can increase or decrease the value of R, but P and Q is fixed. Okay, we cannot increase or decrease, it is fixed value. And this X value is not known, it is unknown. We have to determine the value of X. See, to determine an unknown resistance, here unknown resistance is X, nah? So when the bridge is balanced, at that time we will get this equation: P by Q equal to R by X. And using these equations, since we know P value of P, Q and R, we can easily find this X value. Nah? When balance points means the current in this G, nah? G is galvanometer. Okay, when the bridge is balanced, at that time in this section the current will be 0. Okay, no current will flow in these sections, because at that time when the bridge is balanced, point B and point D will have same potential. So same potential means current will not flow, because current flow only when there is a potential difference, that is from higher potential to lower potential, that is from positive to negative, nah? Okay, now we will obtain the balance condition using Kirchhoff law. Balance condition means this equation we have to obtain using Kirchhoff law. Okay. Okay, first we have to draw Wheatstone bridge, nah? Okay, now in order to solve any circuit, first what you should do, you should first make direction of current, nah? Direction of current. After that you have to sign plus minus, you have to give sign, nah? Plus or minus in resistor. After that choose loop. Okay, choose loop direction, and then apply Kirchhoff law. Okay, now here current direction is not given, nah? Okay, make the direction of current. So starting from the battery, so this side is positive, this side is negative, so current flow from positive to negative. So let's say I current is flowing, nah? So I, here also I, Okay, now we have two branches. Now one is AB and AD. So this current I will divide into these two branches. Okay. So let's say I1 current is flowing in this upper branch. Nah? Let's say I1. So I1 will flow. And let's say here I2 is flowing. Okay, so in this total current is how much? I. Nah? So I. In this I, some part, that is I1 is flowing in this direction, and some part I2 is flowing in this direction. So when we add up I1 and I2, we will get I. Nah? Okay, now, so at point B, here also this current I1 will divide into two parts. Nah? One, it will go in this side, and the other, it will go in this side. Let's say since here galvanometer is there, so let's say the current passing through this galvanometer is Ig. Okay, so if this is Ig, then this side must be how much? From I1 current, just we have taken out Ig current. Nah? So what is the remaining? Total is I1, and from there from that Ig current is in this, going in this direction. So the remaining will be I1 minus Ig, right? Nah? So that I1 minus Ig will flow in this direction, I1 minus Ig. So I1 minus Ig current is in this direction. Okay, so here also I1 minus Ig. Okay, so Ig is coming in this side. So here how much? I2. Nah? So now at this side, how much current will flow? I2 is coming in this side, and Ig is also coming in this side. Now at this point, so the total I2 plus Ig will flow this side, right? I2 plus Ig. So here also I2 plus Ig. Now at point C, this I1 minus Ig and I2 plus Ig is meeting. So the total current will, so the sum of this current will flow in this side. Nah? So that is I1 minus Ig plus this I2 plus Ig. Nah? I2 plus Ig. So you can see plus Ig and minus Ig we can cut. Nah? So here we will have I1 plus I2. Nah? So I1 plus I2. What is this I1 plus I2? See, at this, okay, nah, okay, at this junction A, this I is equal to how much? I1, nah, plus I2, right? Or if you don't understand like this, then apply current law, nah, Kirchhoff current law. So sum of current will be 0, nah. So current going into the junction is positive, and current going out of the junction is negative. So I plus I2 is current going out of the junction, so it is negative, nah? Minus I2. Same as I1 also, it is going out of the junction, so this is also minus I1, so this must be equal to 0. So I minus I2 minus I1 equal to 0. So I equal to how much? This I2, and if you take this I2 and I1 in this side, then it will this minus will change into plus na, and this minus will change into plus. So I2 plus I1 na. So this I is equal to I1 plus I2 na. So I1 plus I2 is nothing but I. So this I1 plus I2 na. This I1 plus I2 is nothing but I. Okay. So instead of writing I1 plus I2, you can write I also. Okay, done na. Current direction is done. Now what? We have to make sign na. Okay, so this current is in this side, so this must be plus and this must be negative. Here also this side is plus and this side is minus. So here also this side is plus and this side is minus. So this side is plus, this side is minus. Okay, all the current direction is done and sign also done. Now apply KVL, Kirchhoff voltage law or second law na. So for that we need loop. Okay, first one loop, second loop. So first loop is A B D A. Loop A B D A na. Okay, starting from A. Okay, we are going this side na. So plus, this is plus, this is minus na. So that means minus what is the current? I1 P. I1 and resistance is P na. So here we are talking about voltage. Now voltage formula is V equal to current into resistor na. So this I1 is current and this P is resistor. Okay, now we reach at point B. So we have to go down na. Down, since there is no resistance. So now we have reached D. From D we have to go this side again A na. Since D to A, right? So D to A we came across resistor and the current is I2. So minus plus. So ending one is plus, so you have to take plus. Plus here also I2 current into resistor. Resistor is R. So this must be equal to 0. Nah? Now next loop is loop BC DB. BCDB. Second loop. Okay, starting from B. Now we have resistance, so we are going like this. Nah? So that means this is minus. Nah? Minus current is how much? I1 minus IG. So minus I1 minus IG into resistor. Resistor is Q. Now we have reached at this point, that is C, point C. Now we will go this side. Nah? So minus to plus. So that is plus. Current is how much? This is the current. Nah? I2 plus IG. I2 IG and resistor is X. Nah? X. Now we have reached D. Now from D to B, nothing is there. So equal to 0. Okay, now you have to arrange. So this one do I can write minus I1 into Q minus plus IG into Q plus I2X plus IGX equal to 0. So this is 1, this is 2. Nah? Okay, now at null point or at balance point, So what did I say? At balance point, what will happen? Here this Ig will be 0 because at balance point in this branch no current will flow, so this Ig is 0. Nah? At balance point Ig equal to 0 because potential at B and D are same. So since they have same potential, so current will not flow, because current only flow when there is a potential difference from that is positive to negative. Nah? So if they have plus plus or minus minus means same potential, then current will not flow. Okay. So now equate this Ig equal to 0 in, okay, in equation 1 there is no Ig, nah? So but in equation 2 we have Ig, so we have to put 0. So minus I1Q plus this one will be 0 because Ig is 0, 0 into Q is 0, nah? And plus this one I2X, this one is also 0, nah? So make this equation 3. Okay, nah? Now divide. Okay, now compare P by Q. Okay, divide equation 1 by 2, nah? 1 or equation 1 by this equation 3. So what is equation 1? Equation 1 is I1P minus I1P minus I1P plus I2R plus I2R equal to 0. Okay, first, before dividing, arrange this equation 1. Equation 1, okay, this minus is there, na? So I2R equal to, I will write I2R equal to, so this minus term, if we bring this side, then it will become positive, na? So I1P, na? I1P, okay. So make this equation 4. And for this one also we have to do. So I2X equal to, now bring this side. So this minus will change into plus. I1Q 5. Okay, now we have to prove this one, na? P by Q. Okay, P by Q. Okay, now divide 4 by 5. So that means I2R divided by I2X. Nah? This is equal to I1P divided by I1Q. So this I2 and I2 cancel, I1 and I1 cancel. So R by X equal to P by Q. Nah? So we got the equation. Nah? This equation, this one. Nah? P by Q equal to R by X. Nah? So this is same as this one only. Nah? Or X. Nah? So this is the balance condition of Wheatstone bridge.